Hello grade 10, this is Miss Hughes.
And this is Miss O'D.
And today we're going to talk about bearings. Let's get a general idea about what a bearing is. Oops, on the first page. So, suppose this is a big map. And you are standing here and you want to travel to this point here. We would generally say that you travel north, and you're probably used to that. If you're going this direction, you'd be going east. If you're going there, south and west.
What would happen if you're not going exactly north, south, east or west, Miss Hughes?
Let's say, for example, that you want to go over here. You might say that you're going northeast. But you can see it's not very precise, and that's where our bearings come in, the definition of a bearing. So here's the definition of a bearing. It's the clockwise angle. Make sure you write this down. Clockwise angle from north.
That's very important. So you should always draw a north line in from the starting point in every question.
Yeah, so if this is my starting point and this is the north line, let's say I want to travel over here. I want to travel in this direction. Then I would measure the clockwise angle from north, and that would be my bearing. In this example, it would be, let's say, 90, maybe 110 degrees.
Yeah, that's a good estimate.
All right, okay, so let's try a problem involving bearings. Oops. Right, an aircraft flew 10 kilometers south and then 6 kilometers west. Good idea always to start by just drawing the picture. So there's my aircraft, and it's going to go 10 kilometers south and then 6 kilometers west. So that is right, yeah?
Yes.
Okay. All right, and it says, what is the bearing from its starting point? The word from is really crucial in this problem.
Definitely.
So you're going from here to here. And the word from tells me where to draw the north line. Okay, Mr. D, do you want to do the next bit?
Sure. So we always are looking at where we turn from north. So we start at our north line. We're facing north. It's like we're standing there facing north. We have to turn clockwise because bearings are always measured in the clockwise until we get to the blue line, because that's our path that takes us directly to where we now are. So where the green arrow is, that's the angle we're trying to find. Now, we can find parts of that angle already because we know about what we know about north, south, east and west. So we know that already part of it is 180 degrees, that bit on the outside. But then we have that little extra bit between the red and the blue line there, and we don't know how much that is. We don't know that angle. So now we might have to use some trigonometry, I think, to find that angle.
Yeah, luckily we've got a right angle triangle, so let's try and use some trigonometry. Now, in that case, it's often a good idea to just isolate the triangle that you're looking at. Oops,
good idea.
Not a very right angle triangle. There we go. We know that this is 10. We know that this is 6. And we're trying to find this angle here. Let's call it x. So don't skip any steps, remember. So start with labeling the sides: hypotenuse, opposite, adjacent. I'm not interested in the hypotenuse, so we're going to use tan.
Very good, yes.
So tan x equals the opposite. Do you always write the formula first?
Always right, yep.
Yeah,
so
me too.
Set it up.
Opposite over adjacent. And then we'll do some substitution. So tan x equals, the opposite is 6, the adjacent is 10.
Now we have to find an angle. What's that extra step we have to take, Miss Hughes, when we have to find an angle with trigonometry?
Well, we have to get rid of the tan, we have to undo tan, do the opposite of tan, so that's inverse tan.
Good.
There we go.
Don't forget the inverse tan, that is written above the tan button in blue. So that means you have to do second tan when you put it into your calculator.
Yep. I'm just going to check that we're on the right mode.
Oh,
no, see.
Lucky you checked.
We did this last time. We need to be in degrees. Okay.
And remember, if you're not on the right mode, because you'll normally get weird sorts of answers that don't really make sense.
that doesn't make sense.
Maybe it's still on radians.
Didn't press
See?
enter.
We knew it didn't make sense
Classic.
because of the radians.
Okay, let's try now.
So not likely that it would have been an angle of 0.5.
Second tan, 6/10, which is 0.6. You could
Of course.
do that as well.
Yes.
There we go, that's more reasonable.
That looks better.
So, x equals 30.6963 ... So let's say roughly 31.
And don't forget then, because we're finding the bearing, we want to find the whole angle that we're turning from north. Remember, we're actually finding that green angle. So don't forget to add the 180 now. And so we get 211 degrees.
And that's our answer. Usually we have to give 3 digits for our bearings, right?
Yes.
That's the convention. So if you did end up with an answer that, let's say, was 27 degrees, you would put a 0
Yep.
to ensure that you're giving 3 digits. Okay, next problem.
Okay.